manage. Next, I call upon Dr. John Davis. He needs no introduction. He's an innovator par excellence, and he keeps moving forward with a lot of new ideas and a lot of new innovative stuff that comes from him. Let us hear from him. Over to you, Dr. John.
Thank you, Dr. Vijayaraju, sir. And I am going to present my 3D printed innovations. So, I have some financial interest because I am making some commercial devices from 3D printing. Some of my designs are open source and free. If you scan these QR codes, you can download those 3D designs. You can print those 3D designs and use it in your hospital. PGs and other people, take a photo right now, take out your smartphones. Most of the time we tell no smartphones. Now we say, take out your smartphones, take photos. These QR codes, you can download the 3D designs. Okay, I think we are going to the next slide. So the process of 3D printing starts with designing. Using CAD software, you design something and then you use a slicing software to slice it and convert it to G code, which is what the 3D printer understands. And then you send it to a 3D printer, and then there is some, after 3D printing, there is some post-processing. You will not get exactly a very good finished product. You might have to use acetone or heat or UV to finalize the product, and that product can be used either as a prototype or even as a final end product. This entire part of slicing printing, you could outsource to a 3D printing shop. If you open Google Maps and search 3D printing near me, you will find 3D printing shops. So materials, a lot of plastics, PLA, ABS, nylon, and you can even 3D print in titanium, but that requires a different 3D printer. The plastics 3D printer, that is the filament based FDM 3D printers, start at around 15,000 rupees. Yes, not dollars, rupees. And the resin printers start at around 20,000 rupees. So very affordable. Somebody has a birthday and you want to give a gift, ideal gift. My birthday is coming soon. So, so there's a lot of techniques of 3D print. The ones which you need to know are the FDM and the SLA. FDM uses a spool of plastic and uses that to melt together the plastic into the design that you need. SLA resin printer uses a liquid resin which polymerizes with UV light. Much faster and much higher resolution with the resin printing that is available in all the dental labs also. So 3D printing shops, if you cannot find, go to a dental lab. They have these 3D printers. Or your engineering friend, they have these 3D printers at home. So over to the next slide about ophthalmology. Starting from cornea to retina, there is a lot of 3D printing involved. We'll get to that. And we have accessories, processes, implants, adapters, even for surgical planning and teaching. So 3D printing has a lot of uses. And my 3D printed innovations, I'll go through those quickly. So it's a magic device. So you can think of something and then make it come to reality. So about, yes, article on 3D printing in Kerala Journal of Ophthalmology. All of you, please publish in the Kerala Journal of Ophthalmology. It's a very nice journal, no publication charges, no financial interest. So one of them is the eye drop guide, which Dr. Ankit will be talking about soon. So I'm not going into detail about that. So I tried to mentor some PGs and students into doing stuff. This is a 3D printed punctal plug and drug delivery system. I was in Ramchandra Medical College. I was teaching the MBBS students. I told them, you can do 3D printing in ophthalmology. You have, these are the various things which you can, which are already done. These are the things you can try. And they wanted to do a project. 2 MBBS students in 3rd year of MBBS ophthalmology posting came to me and said, sir, I want to do a 3D printing project. This is what we did. We sat together and planned it out. They drew the 3D printed design. They 3D printed in the dental lab. And they came to me and said, sir, we 3D printed this. So this is what is possible. You can think of an idea and make it a reality with the magic of 3D printing. Another one is a glaucoma drainage device. I wanted to start doing implant surgeries, so glaucoma drainage devices. And I wanted to get an implant so that I can practice in the wet lab. I said, why not draw the design and 3D print it? So these designs can be downloaded from these websites. So designed this, made the 3D print, implanted it in a wet lab in Goldsai. So that is for wet lab practice. You can also use it for innovating new design. Suppose you think of a new design of a glaucoma drainage valve which has a variable controller. Design it, print it, test it, design doesn't work, again, make it again, iterate, find out what works. Once it is final, you can finalize it into a proper design, right? MIGS implants, so lots of MIGS devices are there. I wanted to, get into MIGS, so drew that MIGS designs, 3D printed them, even made them in augmented reality. So this is augmented reality. You can have this in virtual space in front of you. You can pick it up in your hand, move it around. You can do this for teaching, PGs, patients, whomever. So any 3D design you can use in augmented reality as well. Then cataract surgery instruments. This is phaco probe, IOL, dialer, chopper, IA cannula. These are various glaucoma drainage devices, RD, CTR, CTS, everything. And dehexering, of course. You can download and print, okay? Or you can put in PowerPoint. So all these 3D models flying around, the same files put in PowerPoint as a 3D model, okay? Very easy to do. And next you have the cataract surgery big model. So cataract surgery training, it's very difficult to see. So we designed a big model of cataract surgery. So this is a stained anterior capsule. This is a yellow nucleus, and behind it you can see the orange-red glow. So all these things we 3D printed in huge size, so that when you teach your residents, you can tell them, this is a nucleus piece, this is how you lift it up, this is how you chop. All those things are much more clearer when it is big. So big sized cataract surgery, 3D printed. Then of course the foldable fundoscope, inspired from Dr. Bijuraju. We designed a fundus camera, but I wanted to make it more and more portable. So I made it into a foldable pocket size design. Again, drew this myself and 3D printed it, made it a reality, and patented it. So that is another thing which you can do with 3D printing. You can think of something which you want to make, you can make it, patent it, and win awards also like this. Yeah. So this is about the foldable fundoscope, and I think that's it. Thank you. Hope I inspired everybody to buy their own 3D printers, start 3D printing, and these are the sites where you can design 3D things. Tinkercad.com, or you can go to Google Maps, find a place where you can 3D print. You can design 3D designs in AI, Meshi.ai. You can design 3D designs. You can just give a photo and tell it to make something, or you can give it in text also, Hyper3D.ai also. So you don't have to learn 3D printing, you don't have to buy a 3D printer, you can do it all, okay?